In this video, we'll be talking about risk assessments in the criminal justice system. These are used to make decisions about whether to commit a person to some form of detention or to release someone from detention, whether that is in prison or a secure mental health facility. We'll look at whether risk assessments are accurate, how they are made, and the sorts of information and considerations that may be taken into account. So, when might you have to assess risk? One of the times that a risk assessment is done in this context is when a person first arrives at prison. There's a range of reception processes that prisoners go through when they arrive at a prison. These include having their property logged and going through a formal identification process. A number of assessments are also conducted to identify their personal needs. These include program, educational and medical assessments, as well as an assessment to determine whether they are at risk of harming themselves or others, or of being harmed by others. The assessments are used when developing a case management plan for the prisoner. So, the psychological component of the assessment at entry has two purposes. The first is to assess the prisoner's dangerousness to maintain the security and safety of those in the prison. And the second is to assess the prisoner's treatment needs so that the appropriate interventions can be undertaken. Risk assessments might also be conducted at times of psychological crisis for the prisoner. For example, if the prisoner attempts to commit suicide, shows signs of emotional agitation, psychotic behaviours, refusal to eat or participate in prison programs. Finally, risk assessments are conducted when decisions are being made about the prisoner leaving detention before the full duration of his or her sentence has elapsed. Now, in making this assessment, the parole board will take into account a number of factors. These include the nature of the offence, past offences and any patterns of offending, the possibility of further offences, whether the offender has breached any conditions of a previous order, whether the offender has successfully completed programs of rehabilitation, the institutional conduct of the offender whilst incarcerated, the viability of the offender's relapse prevention and release plans, the risk of physical or psychological harm to a member of the community, any behavioural report relating to the offender, and the sentencing judge's recommendation. So how is it possible to make this decision? Well, there are two general approaches as to how to make predictions about how the prisoner is likely to behave if released. The first is called the clinical approach. In this approach, a mental health professional will use their judgment to evaluate the available information and arrive at a decision. There is a tendency for these assessments to focus on a narrative explanation for the prisoner's past and future behaviour that gives causal explanations for why things have happened or might happen. These essentially form a story that helps predict the risks posed by the prisoner. The second approach is what we might call a statistical or actuarial approach. This essentially uses an equation derived from quantitative information to make decisions. It is essentially a factual account of a prisoner's conduct. So, which is the best way to make a risk assessment? Well, one way of thinking about it is that the most fair and ethically defensible approach is the one that has superior predictive ability. That is, the one that can most accurately predict what will happen. So then, which method has the best predictive ability? In 1986, Meehl reviewed 90 studies comparing the two methods. In all but 6 of those studies, the statistical technique was more accurate at predicting behaviour. Sawyer's earlier research in 1966 suggested that the actuarial or statistical approach performed better at both collecting information and at combining information. Now, why is this? Why doesn't a clinician's experience and training produce better predictions than a mathematical equation? Well, many people certainly seem to prefer clinical-based assessments over statistical assessments. One of the assumptions about clinical assessments is that the expert will take into account the best knowledge in their field. Now, the unique circumstances of the prisoner may be given particular weight in evaluating the potential for risk. The problem is, however, that there is no routine follow-up of cases to find out whether predictions are accurate or not. And given the lack of feedback given to clinicians making these predictions, there's very little opportunity for them to refine the way they make their predictions by learning about what factors are actually related to reoffending behaviour. Taking into account the personal circumstances of the prisoner is probably what contributes to clinical assessments appearing more attractive than statistical formulas. But as we mentioned before, the research suggests that statistical models are actually more accurate. To understand why, it's worth spending a moment talking about how statistical predictions are actually made. The first step is to choose one or more criterion variables. This is the behaviour you're trying to predict. This could be any one of the following: arrest, conviction, or involuntary hospitalisation rates. Next, you identify predictor variables that correlate with the criterion variable in the population of interest. Now, the population might be mentally ill who were recently released from a hospital, or former sex offenders, or any other appropriate group that matches the general characteristics of the person for whom you're making the risk assessment. We use published research to help us identify the relevant predictor variables. The predictors could be present variables such as IQ, past variables such as the number of prior arrests, or demographic variables such as age, sex, socioeconomic status, race, or marital status. We then use a statistical formula to combine the predictors, giving each variable a weight based on the past research, which has shown how strongly it is correlated with the criterion. It might look a little like this. In this formula, we have age, gender, and socioeconomic status in the formula, because presumably we have referred to research showing that these are important predictors of risk for the population that this prisoner comes from. You will notice that each of these factors has a weight as indicated by the W1, W2 and W3 parts of the formula. These weights, as noted before, also come from prior research and represent how important the various predictors are for estimating the risk level. The result of applying this formula is a risk estimate of either low, medium or high. So why are statistical predictions more accurate than clinical predictions? Goldberg in 1991 argued that they're more accurate due to a number of factors. The first of these is validity. Statistical tests adjust for the value of different information. That is, whether that information is actually related to an important outcome or not. For example, research by Quinsey and Maguire in 1986 found that when making decisions about parole, experienced clinicians rated the frequency of aggression within the institution heavily when assessing dangerousness. Now, aggression within the prison is in fact actually unrelated to reoffending or recidivism, and statistical models take this into account. The second reason for the increased accuracy of statistical models has to do with the units of measurement used to represent the information. Statistical techniques can easily combine information that's measured on different scales. Humans, on the other hand, tend to overuse information presented in the same metric as the outcome, and so such information becomes disproportionately influential in any risk assessment simply due to being represented in the same way. The third reason is reliability. And people are good at identifying what information should be considered in making a prediction, but they're terrible at consistently applying a single prediction formula. Statistical formulas reliably combine information in the same way each time they're used. The fourth reason is redundancy. Statistical techniques give less weight to redundant variables, that is, variables that represent the same information. Humans, on the other hand, much prefer redundant information as it is confirmatory. Information that is similar to other information seems to suggest that it's truer and should be given more weight. According to Goldberg, a final reason for the improved accuracy of statistical predictions is the presence of regression effects. Extreme observations should generally be followed by less extreme observations. Part of what makes an observation extreme is due to an underlying effect, but also partly due to error. And error can be positive or negative, and so extreme scores partly represent a possible effect plus error that just so happens to have been observed in the same direction as the effect. Given that error is often random, it's likely that the next time we make an observation, the error will not be in the same direction. And so our observations should tend to become less extreme. This is called regression to the mean, because our observations tend to gravitate back towards the average or mean. Humans, however, expect extreme performance to be followed by further extreme performances. The extreme scores are seen as particularly diagnostic and so overweighted in estimates of risk. Statistical formulae are not influenced by a failure to understand regression to the mean. It's also worth keeping in mind that clinical judgment is influenced by a range of shortcuts and biases inherent in social inference. We've talked about several of such biases in our videos on how jurors and judges make their decisions and how investigators interview witnesses and suspects. Okay, so let's now look a bit more closely at some of the issues when making predictions about risk, regardless of how you do it. An assessment of dangerousness is a probability statement about whether a specific individual will be violent. In a legal context, you have to classify a person into a distinct category as either dangerous or not. To do this, we use cutoff scores to transform a continuous probability estimate into a categorical outcome. Now in this table, you can see the heading at the top represents what is true in reality. The person is either really violent or not really violent. The rows represent the prediction that is made. The person is either predicted to be violent or predicted to be non-violent. Correct decisions are the true positives, which is saying someone is violent when they are actually violent, and the true negatives, saying someone is non-violent when they're actually non-violent. These are both sometimes called hits. The accuracy rate is the total percentage of hits. The problem is that because predictions are not perfect, no matter what cutoff point we use, there'll be some errors in prediction. If we set our cutoff to be very low, that is, we say somebody is dangerous even if the probability of dangerousness is relatively low, we'll certainly make a lot more true positive decisions, but we'll also make a lot of false positive errors. This is when we say the person is going to be violent, but they're not actually violent. This isn't a good outcome because somebody might be kept in prison even though it would be safe and better for them to be released into the community. If we raise the cutoff point to reduce these errors, and so now we only predict someone will be violent if we estimate that there was a high probability that they are dangerous, we make more true negative decisions and fewer false positive errors. However, we now make a different type of error. This error is called a false negative, which means we say a person is non-violent when in fact they're actually violent. This is also not a good outcome. We're recommending the release of someone who's still dangerous. If this problem sounds familiar, it's because we've talked about exactly the same issue in the lie detection video when we considered the accuracy of polygraphs. Polygraphs have the same issue because they also try to convert a continuous measure, which is your body's physiological response, into a categorical statement about whether you're being deceptive or not. Remember in that video we talked about how base rates also dramatically affect the types of errors that we make. Basically, the proportion of these two types of errors, false positives and false negatives, is influenced by base rates as well as cutoff scores. The base rate is the percentage of people in an entire population of interest who exhibit a given behaviour over a specified time period. As noted by Meehl and Rosen in 1955, when we have a low base rate, the rate of false positives will be high even if the prediction technique is very accurate. Remember that accuracy is the overall percentage of correct decisions, or hits. For an example, let's consider the prediction of whether a prisoner who has served time for a serious assault will re-offend. Assume that the base rate of assault is 10% and our measure will detect 99% of people who will assault others. This is the sensitivity of the measure. Assume also that the measure will detect 99% of people who will not assault other people. This is the specificity of the measure. As can be seen from this table, 990 out of 1,000 people are accurately predicted to commit assault, and 8,910 people out of 9,000 are accurately predicted not to commit assault. As such, the accuracy of our measure is 99%, and so only 1% of people, or 100 out of 10,000, will be misclassified. Of those misclassifications, they are 9 times more likely to be predicting that a person will commit assault when in fact they won't. Now this sounds pretty bad, but errors in predicting that a person will offend when in fact they don't only make up about 8% of predictions that someone will offend. Now let's assume that the base rate of assault is actually 1%, and again our measure will detect 99% of people who commit assault and 99% of people who will not commit assault. Now we can see that there are 99 people correctly predicted to re-offend and 9,801 who are correctly predicted not to commit assault. The accuracy rate is still 99%, but our 1% misclassifications are very different. Of those misclassifications, it is now 99 times more likely to be predicting that a person will commit assault when in fact they won't. This is 11 times worse than before. Now we have 99 people who are predicted to offend, but in fact who won't. And this represents 50% of the predictions that someone will offend. This is a much worse outcome than before, and shows you what happens when base rates become low. Even though our accuracy rate, or the proportion of correct decisions, stays the same, our confidence in the correct positive prediction should be dramatically reduced. While we make very few errors when predicting that someone will not re-offend, we make many more errors predicting that someone will re-offend. This can be so bad that we can make just as many or even more errors compared to correct judgments when predicting that someone will re-offend. Thus, it's especially important that we take into account the method of predicting risk, the accuracy of the method that we use, and also the underlying base rate of the behaviour that we're trying to predict. Without a proper consideration of all of these factors, our predictions could in effect be no more reliable than chance. So it seems that there are reasonably high error rates, Monahan in 1981 in fact concluded that psychiatrists and psychologists were only accurate in one of three predictions of violent behaviour, despite the fact that these predictions were made in relation to a population of people who had a high base rate of being violent. This is probably partly because even in such groups with high base rates of being violent, the majority of people still do not commit acts of violence, thus inflating our false positive errors. This is a bit of a problem if you're writing a report for a parole board. So, how can accuracy be improved? Well, research has identified a number of areas for improvement. So far, relatively limited samples have been studied, mostly men with past histories of violence. Information from these samples is obviously not helpful if we're trying to make predictions about women or about men who have no history of violence. Study of risk assessments have also tended to focus on a limited number of potential predictors, such as age, gender, race and ethnicity. Silver and colleagues have suggested that it would be worthwhile to take into account socioeconomic status, employment stability, intelligence and drug and alcohol use. This is because all of these factors are related to arrests for violent crime. You might also be able to improve accuracy by including dynamic factors such as current employment status or current degree of anger. Considering the influence of the situation and how it might trigger violence in different individuals may also improve predictions. So in some senses, we are back where we began in this course. In the same way that we do not know with much certainty how to predict who will become a criminal or who exactly an offender is, it is difficult to predict who will maintain their criminal lifestyle and re-offend. Although this might seem like an unsatisfactory way to conclude, it does highlight the important role that evidence-based research has to play in improving how we make these difficult decisions at these stages of the criminal justice system, but also more generally in how we investigate, prosecute and decide cases.